Hello and welcome back. Today we're talking about factoring. And we're talking about factoring the greatest common monomial factor from a polynomial. So, when you are looking at this chapter in your math textbook, you might notice that there is more than one type of question that you'll see. You could see factor out the greatest common factor, and you also could see find the greatest common factor. So if you just find it, then that's all they want to know is what it is. But if you have to factor it out, then you find it, move it to the left, and then you're going to write basically a math problem that shows how you can distribute that greatest common factor into the other numbers. Okay, so first of all, we're going to start off looking at these problems. It says, hold on, let me move this up. Okay, so this question says just to get the greatest common factor of a set of monomials. And this is basically your introductory type of question where that's all you need to do is just find it and bring it out. So, here are the monomials. 15xy, 10x cubed y squared, and 25xy cubed. Okay, so you're going to write each of these monomials separately so that you can, and I think writing them vertically, this is what I choose to do, but it's up to you. I mean, because if you wrote the monomials horizontally, then you'd have to write the factors underneath them. And they have variables that are raised to different powers and whatnot. So I just wrote them vertically so that we can write out horizontally from left to right what all the factors are. Okay, so starting with the first one. 15xy equals 3 times 5 times x times x times y. And what I'm wondering right now is how I managed to get 2 x's for 15xy. Okay. Okay, the first problem actually, we'll put a square there. Okay. Yeah, it's more interesting with 2 x's, so we'll go with that, and we'll make it 15x squared y. 3 times 5 times x times y. Okay. The second one is 10x cubed y squared. And we're going to factor that out is 2 times 5 times x times x times x times y times y. Okay, moving along. 25x y cubed. We're going to factor that out as 5 times 5 times x times y times y times y. Okay, so now you're beginning to see how we can do a factorization for variables. You just write them from left to right, and if it's raised to a certain power, that's how many times you write it. Okay, so looking at all of these elements of our terms, which ones do you think they all have in common? So let me switch to a different color. I see that they all have a 5. They all have at least one x, but they don't all have two x's. So we're just going to leave it to end. They all have at least one y, but they don't all have two y's. So the greatest common factor of that set of monomials is 5 times x times y. All of the terms in that problem have this in common. They all have a 5, they all have an x, and they all have a y. Some of them have more than one of the variables, but they would all need, we're looking for what they all have in common. So now that we've done that, we can write it in a more simple form without the multiplication sign, and just put all of these right next to each other as 5xy. And that's the greatest common factor. So we've done that. Now let's look at the second kind of question that you will run into. The second question is factor out the greatest common factor. Okay, so in number 2, we're going to have to do something after we find the greatest common factor. Okay, and the question, let's say the question in the textbook or on the exam says says factor out the greatest common factor from 5x minus 15. So we'll start with 5x. 5x equals 1 times 5. And you'll notice on the, I will call it the coefficient of that variable, it only factors down to 1 times the number itself. So that would be a prime number that we're dealing with right here. 5 is a prime number because these are the factors. The only factors are 1 and itself. And the other thing we have here is an x. So times x. And we're done with 5x. So let's get the factors of 15. 15 equals 3 times 5. You can't factor it any further because 3 is a prime number with only 1 and 3 as factors, and 5 is a prime number with only 1 and 5 as factors. So what we're going to do, well, it's already been underlined. The only thing that these two terms here, these two monomials have in common is 5. So the greatest common factor is simply 5. And that's what we did before in number 1. But the question is different. The question says to factor out the greatest common factor. So after we've done this, and also I wasn't going to show you this, but I'm going to go ahead and take a second to show you this. In the previous problem, there were no operators in between these monomials. It was just a comma. It's just basically a list. That's also how you know that you're only going to find the greatest common factor and then you're done. There's a list. But here, in number 2, you actually have a binomial consisting of two monomials. So, and in between them, there's an operator, a subtraction sign. So this is basically one whole thing. You could just put it in parentheses if you wanted to. This is like one whole thing here. It's like one whole thing. One number. One term. Okay. These two separate terms are together one term. So that's another way to know that you're factoring it out. Okay, so now that we have the greatest common factor as 5, so it was a 5. You remove it. So we're going to just 5x minus 15 now equals 5, because we took it out, times x minus 3. So basically, if you distribute the 5 into the x and into the negative 3, this is what you get. You get 5x. 5 times x is 5x, and you also get negative 15. And that's the way you check, is that the answer is going to be basically a multiplication problem. And you can just multiply, you can do the actual problem to check and see if you removed the factor, to see if you factored it out. And notice when you factor it out, here was the original problem. 5x minus 15. When you factor that 5 out, you're going in this direction. It's like the reverse of the distributive property. You're taking it out. So basically 5, okay, you can think of it like this way. You write down the 5. And then you ask yourself, you say, well, the first term was 5x. So what do I need to write? And what do I need to put down right here? And multiply the 5 by, so that the answer is the same as 5x. And so you think to yourself, oh, I need to put an x right here. You know. And you say, okay, we need the second term. So the second term was a negative. And then you write the negative down because that's a good clue. It helps you out. So you say, well, the greatest common factor that I factored out was 5. So what can I multiply the 5 by? What can I multiply times 5 in order to get the second term that used to be there? 15, negative 15. So you say to yourself, 5 times negative 2 is negative 10. That's not the right number. Then you say, well, 5 times negative 3 is negative 15. And you're like, wow, okay, I'll put a negative 3 there. And you check it. 5 times x equals 5x. 5 times negative 3 is minus 15. And that was your original problem over here. So you've correctly factored out the greatest common factor. Okay, I think there might be something else on the next page. There is another page with one last problem, so we'll use this as our number 3 today. It says, factor out the greatest common factor of negative 2z to the power of 4 minus 10z. So, you might see something like this with parentheses or without, but it is still a binomial with 2 monomials on the inside. So, we view this as one term together. You're viewing these as one term, and we're going to find the greatest common factor and then take it out and rewrite the problem as a distributive. Okay, so taking the 2z to the power of 4, we're just going to leave the negative signs off right now. We're just going to try to find the greatest common factor as if these were positives first. Okay, so 2z to the power of 4 is 2 times z times z times z times z. And 10z equals 2 times 5 times z. So, they both have a 2. So those are common. And they both have at least one z. So we'll give them one z in common. Is there anything else? No, so we can cross those out if we want to. Moving down here, it says greatest common factor equals 2 times z. But both of the terms were negative, as we can see by looking at the original problem. Both of the terms are negative, so we'll just make that greatest common factor negative as well. So we'll end up with a negative 2z. Okay, so we take our 2z over here to the other side of the page, and we write it down, and then we put our parentheses there, and we get prepared to write some information inside of the parentheses to where negative 2z is going to be multiplied times some other terms. So, in the original problem, we had negative up here, negative 2z to the power of 4. Now, the greatest common factor is just negative 2z. So what can we multiply that by in order to get negative 2z to the power of 4? And the answer is z to the power of 3. Because when you multiply exponents, what you're really doing is adding them. And there's an implied z to the power of 1 right here. So it's negative 2z to the power of 1 basically. So our first term on the inside will be z to the power of 3. And let's go back up to the original problem. The second term, this is funny, the whole thing is one term, but there's also two terms inside of it. So the second term is a negative 10z. Okay, so that's what we need to get, is something we can multiply to equal that. So what can we multiply negative 2z to the power of 1 by in order to get negative 10z? And the answer to that is 5. Negative 2 times 5 is negative 10. And this variable gets attributed to the whole thing. And we don't need any other z's. If we had a 5 to the power of, if we had a 5z, it would be the same as 5z to the power of 1. Then we would have to add those z's together, and our answer would be incorrect. We only need one z. So that's what we're going to end up with, is just a plain 5. We can multiply that 5 times negative 2z and get negative 10z. And basically, at the very bottom where you see it says check, that's what it means to check. When you think you have the right information on the inside of these brackets, always multiply. Distribute that greatest common factor to all the terms on the inside, just to make sure that you've done it correctly. And that's about it. I'm going to put up another video with a couple more examples of this, and they will be more complicated. So stay tuned for the next video, and thanks for watching.